In this video, we're going to look at graphing quadratics using the x-intercepts. And our learning goal for this video is that by the end of it, you should be able to graph quadratic relations in standard form by factoring, which means you'll be able to factor a relation that's in standard form to find the x-intercepts and the coordinate of the vertex. Then based on that, you'll be able to sketch each parabola. Okay, let's jump right in. Okay, so let's write down our question. Find the x-intercepts and the coordinates of a vertex and then we're going to sketch. Then sketch each parabola. Okay, so let's do A. For A, we've got y equals x squared plus 8x plus 7. Okay, so it's important to remember here, I'm going to move this down just because we should write ourselves a little reminder. Let's see, how's there? I think that should be good. Okay, just put a little star here. So we're going to write remember. By definition, to find the x-intercepts, we have to set y equal to 0. Okay, so let's just keep that up there because that's exactly what we're going to do here in our first example. Is the first thing we're going to do is we're going to set y to 0, like so, and then we're going to take a look at this trinomial and start to factor it. I see that I have an a value that's equal to 1. So I'm looking for a product of 7 and a sum of 8. So I'm going to set up my chart here. So I'm looking for factors of positive 7. I should have said I'm looking for a product of positive 7. I should have been more specific. Product should be positive 7, and my sum should be positive 8. Beauty. Okay, I see I have a positive and a positive, so I know both my factors are going to need to be positive. All right, let's start with number 1. As usual, 1 times 7 is 7, and 1 plus 7 is 8. All right, so those are going to be my two factors. Okay. So let's go ahead and break apart that middle term. So we're just going to write 1x for now, just for visual sake. 7x plus 7. Okay. 0 equals, I can skip a line here so I can draw. So let's look at my first two terms and my last two terms. I can pull out here an x, and then I'll be left with x plus 1. And then in my next set of terms, I have 7, and then I've got x plus 1. And there I have created my common binomial. So I have 0 equals x plus 1, x plus 7. Now, if we've gotten to this point in the question and you don't know what's going on, you need to go back and review factoring, okay? So don't worry if you don't understand this yet. That just means you need a little bit more of review. Okay, so now because we've set y to 0, And by definition, that's how we find the x-intercepts. In order to make it true, left side has to equal right side. So I have to look at, let me use a different color here. I'm going to use the blue. How do I make this one true? And how do I make this one true? I'm going to use these colors when I calculate as well to help with the visual here, right? So what I have here, I have x plus 1 equals 0, right? So how do I make this true? Well, I'm going to solve for x. And once I solve for x, I'll be able to substitute that back into the brackets here, right, of 0 equals x plus 1, and I'll be able to have my left side equal my right side. So let's go ahead and solve. I'm going to isolate for x, which means I'm going to bring my 1 to the other side. And that leaves me with -1. So if you think about putting that back in the brackets, -1 plus 1 equals 0. So left side would equal right side. We have to do the same thing for our x plus 7. X plus 7 equals 0. Okay? I'm going to do the same thing. I'm going to isolate for x. X equals -7. So, therefore, let me write it down here. Do I have space? Just a little bit. The x-intercepts are -1 and -7. Great, so we did the first part of the question, which was finding the x-intercepts. Now we have to find the coordinates of the vertex. So we're going to find the x-coordinates of the vertex. Oh, I just realized you can't really see my 2 numbers at the bottom there. My apologies. Okay, let's see if I can somehow fit this all in this little space. I'm going to do my best. So to find the x-coordinates of the vertex, if you remember in chapter 4, is we take both of our x values and we divide by 2. So let's go ahead and do that now. I'm going to just erase this chart here because I'm going to need the space. Okay, there we go. So let's take this all the way up here. So I'm looking for the x coordinates of the vertex. Okay. So I'm going to take my 2 x-intercepts. So I've got -1 plus -7 divided by 2. So that equals -8 divided by 2, which equals -4. Okay, that also happens to be my axis of symmetry. Now to find the y-coordinate of the vertex, we're going to do that down here. I'm going to take the x-coordinate that I just found of the vertex, and I'm going to substitute it into the original trinomial. So we're going to go from this to this over here. Hopefully these arrows aren't confusing you. So I've got y equals x squared plus 8x plus 7. That's what we started with, right? Okay, so let's substitute in our value for x. Got -4 squared plus 8 times -4 plus 7. So that equals 16 minus 32 plus 7. So y equals -9. So I can fit down here. Therefore, coordinates, it's just barely fitting, of the vertex are -4 and -9. Now the last part of this question is asking us to sketch the parabola, which I'm going to do in this little tiny space here. Okay, so go ahead and put in my Cartesian plane. Now with this information here, I can start by plotting the point of the vertex, which is -4, -9. So I'm going to move over approximately 4 spaces and then approximately down spaces. You can actually create your scale for this one. So there's my vertex, and I'm going to label it. Okay, -4, -9. And then I've got my zeros. So if we remember, the thing about our zeros is that when we have an x value, our y is equal to 0, right? So I have one x-intercept at -1, and I know my y value will be 0. So I can go over and move to -1. That's my first one here, -1, 0. And then I've got another one at -7, 0. And now with these 3 points, I can go ahead and sketch my function here. And I'm going to label it y equals x squared plus 8x plus 7. Okay, let's move on to another example to try, but it's going to be a little bit different. It's going to have an extra step in it. So we're still trying to find the x-intercepts and the coordinates of the vertex. So we've got y equals -x squared plus 6x plus 9. Okay? Now when we see a negative value in front of x, we have to factor out that negative value so we can divide everything by -1 or multiply everything by -1. So let's go ahead and do that. So and we're also going to set it to 0, right? Because we're finding the x-intercepts. So I'm going to have -x squared. This is going to become minus 6x. And this is going to, I wrote this wrong here. This is -9. It's because it's going to become plus 9. There we go. Now, what you might notice right here is that you have a perfect square trinomial. Right? It looks like this. A squared minus 2ab plus b squared, right? If you're not familiar with perfect square trinomials, just go ahead and review the video. Okay, so if you are familiar with perfect square trinomials, you can go ahead and just jump to the last few steps. But I'm going to go ahead and factor this fully in case you couldn't notice that it was a perfect square trinomial. And you're going to see once we come to the final answer that in fact it is. Okay, so let's just say I didn't recognize it was a perfect square trinomial and I went ahead and I factored it. I'm going to have to find factors of +9, and that's going to be a product of +9 and a sum of -6. So let me set up my chart. So I need factors here. Factors of +9. Alright, so my product, +9, and my sum, -6. Okay, so when I see I have a positive product and a negative sum, I know that my factors are both going to have to be negative. Okay, so let's start. I've got -1 times -9, that's going to be +9, but when I add that, that's going to be -10, so it's no good. Let's try the next one. Is 3, so I'm going to use -3 times -3, that's going to give me +9, and when I add those together, that's going to give me -6. Lovely. Okay, so I've got my two factors here. All right, so we've got 0 equals negative x squared, and I break apart that middle term, minus 3x plus 9. Okay, I'm going to look at my two groups of terms here. Okay, so we've got, I'm just moving the line down just because I'm running out of space. It's getting a little squishy up there. So I've got 0 equals, I still have my negative. Actually going to draw a set of square brackets here. It's just a second set of brackets to differentiate from the first set of brackets because I'm trying to keep that negative on the outside there. So what I can pull out from these two terms here is I can take out an x, and then I will have x minus 3. And then these other two here, I can take out a 3, and I will also be left with x minus 3. Okay. So if I look at my binomial, what have I got here? I've got x minus 3, and my other two terms, x minus 3. So at this point you should be, if you were factoring and you got to this point and you didn't recognize it was a perfect square trinomial, now would probably be the time that you recognize that, right? Because we have a set of binomials here that are matching. So I can write this, in fact, as negative x minus 3 squared. So this looks a little bit different than our first question, because in our first question we had to look at how we could make it true, right? I'm going to do the same thing here with the colors. So our first x-intercept is x minus 3 equals 0. And I'm going to do the same thing I did before, isolate for x. So x equals 0 plus 3, and x equals 3. Okay. Now, what about my second set of brackets here? I also have x minus 3 equals 0. Oh, okay. Well, I already know that's going to give me, if I go through my steps, x equals 3. That's odd. I have the same value for x. So how could that be that I have two x-intercepts that have the same value? What do you think that means? That means that that's my vertex. So we can write a statement here. Let's write it underneath. Therefore, there is a single x-intercept at x equals 3. This is the x-coordinate of the vertex. Now you're probably wondering, well, how am I going to graph or sketch this parabola if I only have one point here? Well, now that we have the vertex, we kind of have a general idea of which quadrant it's going to be in. But what we can do is, to find more points on the parabola, we can let x equal 0 and solve for y. So let's try that. Let's do that right up here. So I've got y equals negative x squared plus 6x minus 9. Okay, so if I'm going to solve for y, that means I'm going to set this to 0, this to 0, minus 9. So I know anything that's be multiplied by 0 is going to be 0. So y equals negative 9. So that means when x is 0, y is 9. Negative 9. So if I had a Cartesian plane here, and I was going to start sketching, I'm just going to draw this like this. Okay, lovely. I've got the x-intercept of my vertex, and I know that because the x is 3 when y was 0, it's going to be at 3. So I'm going to just estimate here, approximately there. I'll label that. It says 3 and 0. And then I've got a point at x is 0, y negative 9. So I'm going to go ahead and draw a point right down here, approximately at 0, negative 9. Okay? Now, due to the nature of parabolas being symmetrical, and considering that I have the vertex, which is also the axis of symmetry, I'm able to find a third point to help me graph here. So if I wanted to go directly in, if I went directly in the middle of these 2 points, I would get to the vertex. So that means what point over here would give me that vertex and that axis of symmetry right in the middle? That is 6 would be my x value, right? Because over here I have 0, then I'm going to 3, then I'll be up to 6, and I'll also be at negative 9. And now we're able to sketch this parabola, and we will label it as always. It's y equals negative x squared plus 6x minus 9. Now, let's say instead of giving you a trinomial, they actually gave you a graph. So I'm just going to roughly sketch this here. Okay, so I've got a graph that looks like this. So I've got, it's at negative 2, 0. So let's say that's about there. And then I've got one here at positive 4 and 0. And then they've kind of just drawn this graph like so. And they've given me another point on here, somewhere around here. And that's 2 and 16. Okay? So they want you to write an equation in standard form. So y equals ax squared plus bx plus c using the information given in this graph. So let's extract what this graph is actually telling us. Well, I see I have a few pieces of information here. I have a point on the graph at 2 and 16, and then I also notice that I have my zeros, which are my x-intercepts. So I have my r, which is negative 2 and 0, and my s, which is positive 4 and 0. Right? This is r and this is s. So this tells me that my x-intercepts are negative 2 and positive 4. Because I have my x-intercepts, well, I know that I can write this in factored form. What would it look like? Y equals a, do you remember? It would actually be x plus 2 and x minus 4, right? We remember that those signs get flipped to make the statement true. You should review that if you don't recall. Okay, so now that I have this written here in factored form, I can find my value for a. How can I do that? I've already used this piece of information. I've already used this piece of information. Well, they've also so kindly given me an x and a y here with their point. So I have y equals a, x plus 2, x minus 4. And I can substitute that point right in and solve. So my y value is 16 equals a, and my x value is 2. So I have 2 plus 2, and I have 2 minus 4. And this is going to allow me to solve for a. Why are we doing all this? Because they want us to write an equation in standard form at the end of all of this. Standard form up here. So in order to do that, we need these values. So let's go ahead and solve here. I've got 16 equals a, 4 and negative 2. So that's going to give me negative 8a. And to isolate for a here, I'm going to divide by negative 8. Okay, what's that going to give me? A equals negative 2. Okay, so now we can write the equation of this graph in standard form. Let's see, am I running out of space? No, we should be good. So I've got y equals negative 2, x plus 2, and x minus 4. Well, how do I go from factored form to standard form? I'm just going to expand and simplify. So let's go ahead and do that right now. Got negative 2 here, and then I'm going to do my FOIL, distributive property. It's going to give me x squared minus 4x plus 2x minus 8, which is negative 2 x squared minus 2x minus 8. And I'm going to continue expanding and simplifying by using distributive property. So everything inside the brackets can be multiplied on what's the outside of the brackets. So I have y equals, so negative 2 times x squared is going to give me negative 2x squared plus 4x plus 8. Okay, so that is how we write an equation in standard form using the parabola that has been given to us. Now, I know some people like to see a word problem. I'm going to do that in a minute. I just want to make sure everybody sees this part right here, which is just a few different scenarios. That you're going to come across when you are finding the x-intercepts, which are also known as finding the solutions. Okay, so after you've looked at a trinomial and you've factored it, so it's in factored form, so y equals a x minus r x minus s. Okay, let's just say here a is going to be greater than 0, which means a is going to be positive. Okay, you can find that your first scenario will look like the one that we did together, where I'm going to have my two zeros here, right? This is r and 0, and this is s and 0. And when I sketch my parabola, it's going to kind of look like Baby Groot. Okay? There's another scenario we can have when a is positive, which we also saw today, which was y equals a x minus r x minus r. Do you remember when we had x minus negative 3 and x minus negative 3? So really what that is y equals a x minus r squared. So if you come across that situation, you know that the case is that you have actually found the vertex. So it's going to look something like this, right? R and 0. Now, when a is less than 0, so when a is negative, we also did this example. Did we do this example? Actually, I'm not sure we did. But nevertheless, we've got negative a, x minus r, x minus s. Well, if you see the graph for positive a, what do you think this one's going to look like? Right? I'm going to have a downward opening graph with my two zeros, r and 0 and s and 0. And I can have the same thing over here with the perfect square trinomial, y equals a negative a, x minus r, x minus r. Right? So I think it would be helpful for you to have this, just because that way when you have found your x-intercepts, if you found your zeros, you can kind of ask yourself, like, what scenario am I in right now? And that way you can start to actually visualize the graph that you're drawing. I'll just finish drawing this one here, right? Because you still just found the vertex. Lovely. Now, there are some other scenarios that we're going to look at in the next video when we take a look at the quadratic formula, because you might come to a situation where you look at a trinomial and you can't factor it and you think, oh, like it's broken. It's not broken. We're going to take a look at how you can actually use the quadratic formula to work with a trinomial that is believed to be not factorable. Okay, but if you do use the quadratic formula and it's still not working, which means it's still not giving you your x-intercepts, there's actually no solutions. So here we have solutions, right? Our x-intercepts are all solutions here. So we're going to take a look at that in our next video, where it might appear that there's no solutions because the trinomial does not have, appears to be, not factorable, okay? So maybe I'll write a little note for you here, and then you can say like in next video. So let's say if the trinomial appears to be not, oh, it's not showing. There we go. So if the trinomial appears to be not factorable, we use the quadratic formula to confirm. Ooh. Let me start writing it the other way. We use the quadratic, I can fit it under here, formula to confirm. I think I can write it tiny enough that there are, in fact, no solutions. So, aka x does not exist. Right? Because the whole point of this is to find our x-intercepts and find out what they are. So if you are not able to do that, even after you use the quadratic formula, then there are no solutions, right? Solutions are our x-intercepts. There's no solutions. Okay, so I'm going to go ahead and do a word problem. If you want to see how it's done, continue with me on this journey of this half-an-hour-long video. Oh my goodness, you guys are committed. If you're at this point, you're committed. Okay. Let's see here. Okay, so I'm going to use this question. I'm going to write it out and then pop it up on the screen. Okay, so here is the question we're going to work with. It says, to commemorate the 100th anniversary of the Newtonville Fair, an entrance arch will be built. The design engineer uses the equation h equals negative d squared plus 16 to model the arch, where h is the height in meters above the ground and d is the horizontal distance in meters from the center of the arch. So I guess this design engineer needs our help. Concerning, but that's okay because we know how to do this. So let's say the first question is how tall is the arch? So we've got h equals negative d squared plus 16. Well, I am noticing right away that I'm looking at something here that is special. But before I point it out, if we were going to be finding how tall the arch was, that means we'll be finding the vertex. And in order to find the vertex, we have to find the x-intercepts, right? So I'm going to set y equal to 0, or in this case it's h. I'm going to factor out that negative. So I'm left with d squared minus 16. Now I'm looking here at a difference of squares, right? So if we just use the pattern, I know that this is going to look like this. D minus 4 and D plus 4. And that works out lovely for me because the d-intercepts are technically our x-intercepts here, right? So that means I've got 1 point at negative 4 and 0, and I've got another point at 4 and 0. So if we were to sketch this, I mean, you have to try to visualize it as you're reading through the question, right? They're building an arch. It's an entrance arch. So if it's an entrance arch, I know it's going to probably look something like this, right? Because then like all the people, they line up here and then they go inside into the park and there's a Ferris wheel and you're like, yay. Okay guys, it looks like a basketball. All right, let's just erase that. Okay, so if that's what my entrance arch is going to look like, as I begin to visualize what the sketch is going to look like, that can help me. So let me go ahead here and draw. So I know I'm going to have 1 point at negative 4 and 0. I'm also going to have 1 point at positive 4 and 0. But how tall is the arch though? How am I going to be able to find that? Well, we can take our two x-intercepts, negative 4 plus 4, and divide it by 2. If we want to try to find the x-intercept of our vertex, so x would equal 0 over 2, so x would actually equal 0. Okay, so if x equals 0, what can I do with that information? What is x in this equation? X is actually d. So if you take that and substitute it back into our original equation up here, what value would you get for h? Well, I can visualize right now. I know if I substitute a 0 in for that d, it's going to be 0, because anything times 0 is 0. And my h, I'm left with positive 16. So I know that the point of my vertex is 0, 16. So you can go up here to 0, 16. Okay? You could have also tried to, I don't know, visually figure, oh, no, sorry, my mistake. You could not have done it that way. Okay? So that's how tall my arch is. Let's see if they have any follow-up questions here. Okay. Okay, so let's see. They want to know, here. So yes, I was saying they want to know for what values of d is the relation valid. Okay, so what we can actually do here is draw or sketch our function. So that's what the arch would look like. Sorry, the arch is not going underground here, guys. There we go. That's what the arch is going to look like. So I want to ask you for what values of D is the relation valid. I don't know if you guys remember this when we were graphing before, especially in vertex form, like what the values are and what makes it true and real, and how we can't go past certain points for certain values. Well, the same thing is true here. If I have D, D is my distance in what? Meters. My horizontal distance in meters. Right here. Right? So what can my horizontal distance be? Well, if I look over here, I know that D has to be less than or equal to 4, right? Because D can't be 5, 6, 7, 8, or 9 because it doesn't exist over there. Now, what about on this side here? Well, I know that the distance will have to be greater than or equal to -4. So when it's asking you what makes the relation valid for what values, that's what it's talking about. Now, if I asked you how wide is the arch at its base, how could you figure that out? Let me take this away. Well, this situation, they use nice small and friendly numbers for us, right? The arch, I know, is actually 8 meters wide at its base, because if I try to go from -4 to 4, right? -4, -3, -2, -1, 0, 1, 2, 3, 4. So I've got 1, 2, 3, 4, 5, 6, 7, 8 points in between there. So I know it's 8 meters wide. So if they were trying to ask you how wide is it, or maybe how many lineups can you fit in this entrance, like imagine they were setting up sections for people to line up here. So like here, you have to line up in the queue. How many of these can I fit in here? Can I fit 3? Can I fit 4? They might ask you a question like that. We could actually do a question like that. Let's say they were trying to make some lineups in here to keep people orderly, and every single one of these lineups had to be 2.5 meters wide for the waiting area. How do I know how many lineups can fit inside this arch appropriately? Well, I know if it's 8 meters and they want to fit in lineups that are 2.5, not 25, that are 2.5 meters wide, I can just divide. We get 3.2. Well, we can't put 3.2 lineups in there, so therefore we would only put 3. Okay, so hopefully this word problem has helped you to visualize a little bit better what we've been doing. And I encourage you to continue to practice word problems, especially extracting important information and also visualizing in your mind what it looks like what it would look like in real life. Okay? Keep up the hard work.